Do you care how readable your code is? Do you like to express yourself in code? Or maybe you write interesting prose rather than boring code. In today's video, you will learn about BDD and how to write more readable, expressive and elegant tests. This lesson is the second part of serial of lessons on Flutter testing adventures. In the previous lesson, we've learned about TDD and started to develop the crypto wallet app via TDD. If you are not familiar with TDD, I highly recommend going over the first lesson and later coming back here. Keep in mind, you can find the source code in this video on GitHub and follow along with the lesson and practice TDD and BDD immediately. If you are new on my channel, please like and subscribe for more Flutter and software development videos. We already have some unit tests for the wallet class, which we've written in the previous lesson. And there are three parts that relate to the tests. The first part is the source code of the tests themselves. The second part is the test reporting. And the third part is a failure message when a test fails. Let me break some tests to show you what I mean exactly. And with these three parts, we will deal today and improve their readability. Let's start with the first part, which is the code of the tests. And to be very specific, we are going to improve the assertion part of the tests. In the past lesson, I talked about three concepts of verifications. They are expect, assert, and fluent assertion. And today I'd like to introduce the fluent assertion concept. You can find in pubdev a couple of packages that already have implemented this concept, but the first of them is discontinued, and the second has an implementation that I don't like, and I'd like to see the implementation in another way. And for that reason, I've created my implementation of the fluent assertion concept in the package named shouldly. Shouldly is implemented as an extension method for every single type. The first advantage of this library is that it allows you to write assertions as a plain English sentence in a very simple way. Let's quickly compare the same assertion between expect and shouldly manner. For example, to compare two numbers with expect, it will be written as expect play character health 100. But with shouldly, it's written and read as a plain English sentence. Play character health should be 100. We can see this improved readability in other kinds of asserts. Here is how we check that a play character's weapons contain a staff of wonder. If we look at the equivalent assert using shouldly, it reads in a more fluent way. We are saying that the player character weapons should contain staff of wonder. Next, we are checking that the player character's nickname isn't null. And the equivalent shouldly assert here reads, player character's nickname should not be null or empty. And because the player character's nickname here is a string, we can make use of shouldly's additional should not be null or empty method. If the string nickname property is null, the test will fail. But also, if it's not null but contains an empty string, the assert will also fail. So, the shouldly library also contains a number of additional helpful assert methods. Alright, let's rewrite our tests with shouldly. First, we have to add shouldly to dev dependencies. Next, import shouldly into our tests. And we are ready to use shouldly. So our first assertion in the group of empty wallet is that the wallet's coin amount should be 0. Next is that the invested amount should be 0 as well. Next is a group of non-empty wallet, where the first we assert that now coin amount should be 10. And the second, we assert that the invested amount should be 10 as well. Next are groups of invalid amounts and throwing exceptions. Shouldly has a static should class with useful methods to check does the function throw exception or error, or doesn't throw anything. We can check even does the function completes its execution in a period of time or doesn't. So let's rewrite with shouldly the assertions, ways throwing the exception. Good, but does it look like a lot of duplicate code? Would be better to find a way to somehow parameterize a single test. Watch the video till the end to know how to parameterize a test with test cases. And now we are going to rerun our tests that all written with shouldly. Great, our tests are still passing and assertions are written in plain English. And now let's see what will happen if we will break some test. You can see a brand new failure message, which is more readable and easy to understand what went wrong. And this is the second advantage, a more readable and contextual failure message. Let's take a look at some of the test failure messages that Shouldly produces when compared with the testing package which we've used before. On the left, here we've got the output of a non-Shouldly assert, and without looking at the source code, we don't really know what failure this test message relates to. For example, where exactly was the value 10 expected? This same assert using shouldly would result in something more like this. Here it's telling us that the play character health current value should be 10, but instead was 100. So we get a lot more information about exactly what's going on here. Let's take a look at another example. Here non-shouldly failure message is simply saying that we made an assert that something is not null, and this assert failed. With shouldly, we can define whatever expected result title, and it will telling us that the nickname should not be null or empty, when in fact it was. So again, this failure message is giving us a lot more contextual information. Here we've got an assert failure message where we are not using shouldly, and this test is expecting that a stuff of wonder exists in the collection. But again, we don't get much contextual information in this failure message. If we take a look at the equivalent failure message using shouldly, we can see that the player character's weapons should contain stuff of wonder, but it doesn't, and that's why the test is failing. When we are using shouldly for our assert, we get much richer assert failure messages that contain a lot more contextual information about why the test is failing. And that messages are read a plain English sentence. There are more reasons why you would prefer shouldly. First, when writing asserts, one of the things that can cause annoyance or errors is mixing up the expected and actual parameters. Here's a couple of asserts using expect method from test general package, and we are just checking that the expected player character's health is equal to 0. Notice that in the first example the expected value 0 is coming in the second parameter, and in the second example it's coming in the first parameter. So while of course IntelliSense will help us to know which is the expected parameter and which is the actual parameter, it can sometimes mean additional mental effort to make sure we've got the expected and actual values in the correct places. If we compare this to shouldly, notice here that there is no way we can get the expected or actual values mixed up, because we are simply saying play character health should be 0. The only parameter in this code is the literal value 0, which represents the expected value. But there is more. Expect method actually has second parameter named matcher, type of dynamic. And what if we try to use a matcher is 0 and mix up it? We do not see any compiler errors and warnings, right? But guess what? After running this test, we will get some weird failure message like expected 0 and the actual a value equal to 0. I like in Shoodly that the assertion methods are separated by type of class, and you get relevant assertion methods for exact type of result variable. You will not find that the number can be checked on true or false. There is no one big heap where you are looking for the right assertion method. You can use conjunctions to add multiple asserts for single expected result value. For example, 13 should be odd and be greater or equal than 13. Or participants should contain Andrew and not contain Bobby. Shoodly can satisfy all conditions. This is the idea of multiple assert failure reporting. So if a single test method has multiple asserts within it, we can group these asserts using Shoodly. And then Shoodly will report on every failing assert rather than the test just failing at the first failing assert. And with Shoodly, it's easy to create custom matchers. And with Shoodly, we can assert that the function under the test executes within a given expected time period. And if it takes longer or less, then the test will fail. That's pretty much it about Shoodly, and please feel free to contribute to this Shoodly package. So far so good. With Shoodly, we've improved readability of assertions and failure messages. But there's the rest part of the test code which we can improve as well. And for this, we need to get to know with such a methodology as BDD. BDD stands for Behavior-Driven Development. Behavior-driven development was pioneered by Dan North back in the early zeros, as he explained in 2006 in an article called Introducing BDD. BDD is all about collaboration between teams, and to be very specific, it's a collaboration between business teams and technical teams. In any organization, we have business teams with ideas and requirements who understand users' scenarios, how users interact with application. And then we have the technical teams, where we have developers and testers who do the implementation part. And usually, there's a gap between the understanding of business teams and technical teams. And BDD is all about bridging this gap. Using a BDD process, we can build a common understanding between the teams on the behavior of the application. The BDD process generates common documentation that can be understood by all the teams and all the stakeholders. And this documentation serves as a single source of truth for all teams in the organization. Let's take a look at a typical BDD process in an organization. It starts with a user story for any new change or enhancement. A user story is an informal, general explanation of a software feature written from the perspective of the end user. Once we have a user story, we do a meeting between different teams and we discuss the user story. This conversation and discussion on how the system should behave. There are some examples discussed and created, and they are named as scenarios for the feature. And then finally, these examples are agreed upon and approved. These examples are documented in a way that can be used for development and also for testing and automation. And the same examples in the document can be used by business team as well. And then we finally go into the coding phase, where the implementation is done based on the documented examples. These documented examples are structured enough that they can be written as a test and implemented. In the coding phase, we create tests, and these tests guide the development in a way that we need. Here is an example of successful login scenario. Given I am on the login page, when I attempt to login with valid credentials, then I am shown the application dashboard. And here a given portion tells the starting condition for the example. When line tells what you actually do, and then tells what results are expected. Here are 2 points. First, this example is not a unit test example, it's the integration test example. Second, you can say that the business team will not discuss how a class should behave, and you are right. Right now, for unit tests, we should know about the given when then structure to describe our unit tests. Later in this course, when we start to write widget and integration tests, we will invite the business team. And before we jump into the code, I'd like to show you another diagram where we can see where TDD and BDD are similar and different. Both are using the test-first approach, and they are automated. In TDD, we write a tests which called unit tests, and in BDD, we write scenarios. In TDD, we test a single unit which is a function or class, but in BDD, we test a feature of a system. In TDD, only programmers, rarely with testers, write the tests, but in BDD, there are many teams who write the scenarios. In TDD, tests are written from a programmer's standpoint. In BDD, scenarios are written from an end-user perspective. TDD suits unit testing, but BDD is more for widget and integration testing. And maybe you are already wondering how TDD and BDD come with each other. Let's look at the next image. Everything starts from business idea, and teams do meetings and use the BDD process to understand how a system should behave, as we discussed earlier. And after developer starts to discuss with computer and write the implementation of the system that is driven by TDD. Alright, let's come back to our test, and now I'm going to rewrite the rest part of the test code with BDD style, with given when then format. We will rewrite the same unit test but with BDD style in separate file and call it wallet BDD style unit test.dart. To bring BDD style into unit test, we need to add the given when then unit test package to the dev dependencies. Next, I should import the package, and let's import other necessary packages as well. They are our models and shouldly. Next, create the main function. So, the first tests were about testing an empty wallet, in which case the coin amount and invested amount should be 0. And tests literally will be written as given empty wallet. Next, we initialize the wallet object. Notice, instead of setup test fixture, we use more understandable before test fixture. And we assert then coin amount should be 0. And invested amount should be 0 as well. Notice how test code became more readable as a plain English. Let's run our tests, and we see how test report became more readable as well, without much effort. And how the report copies the test code, and I think it's pretty awesome. Next, it would be better join the assertions with and conjunction, isn't it? We can do it. Then method has a parameter end, which is a map of strings and functions, where the key is an assertion description and value is assertion function. In our case, we can simply copy our second assertion and paste it into the map like that. Run test again and see the result. We just joined two assertions with and conjunction, and the test report is still very readable. Next, we can format the test report where all given when then keywords will be on separate lines. For that, we need set a property given when then option paths where we specify padding. For example, let's set it as 2 and run the tests again. And we can see even more beautiful formatting. Next, we need to test a case when we buy some coins and check that the wallet contains proper coin amount and we've invested the correct dollars amount. We specify within when block the before test fixture where we describe the buying action. Next, we add then part with assertions. Run the test again and see the report. Nice. In testing, it's important to test the unit, function or class with a variety of parameters to make sure that all cases are tested. In our example, we could test like we bought 1 coin per $10 or 100 coins per 1 cent. And we could duplicate almost the same test code except input and output parameters. The duplication isn't good, right? Fortunately, there's a better way to test the variety of cases. I will remove this ugly duplication. And for testing these test cases, we should use the test cases method. There are many of them, which depends how many parameters the test case needs. The test cases method has two parameters. First, array of test case objects, where for each case we specify its input and output parameters. And second is a callback, which will be run for every single test case from array of test cases. In our case, we should use test case with 4 parameters. First two parameters are inputs, and last two are outputs which we expect. In first test case, we buy 10 coins per $1 and expect 10 as a coin amount in wallet and 10 as in invested amount. In second test case, we buy 20 coins per $2.50 and we expect 20 coins in wallet and $50 as invested amount. Next, I will declare a callback with test case and copy the when block and will use the values from the test case instead of hard-coded values. And parameterize the test description like when we bought some coins, value of which comes from first argument, and price of coins comes from second argument. Then coin amount should be equal to third parameter and invested amount should be equal for fourth parameter. Let's run our tests and see the test reports. And you can see for every test case there's its own report. Like that, with the test cases method, you can test many cases without duplication the code. Alright, next we have to test the cases with throwing exceptions. We will use the test cases method as well, with test case object with single parameter, and test two cases with 0 and negative amount. And we describe the test as when we add an invalid coin amount, then should be thrown exception. Let's run our tests. And we see the test report for both cases. The similar test we should add for testing throwing exception when user try to invest negative invested amount. But I will skip it now for you to practice later. So far, so good. Let me commit our work and we will continue the development of the crypto wallet app. Let's add new functionality to our application, which is the P&L calculator. that will help us later to calculate our profit and loss in real time. As we practice TDD and BDD, first we need to write tests and describe the behaviors of the P&L calculator, and thereafter add its implementation. First, I will create P&L calculator test.dart file. Add unnecessary imports, add the main function, and try to write the test which describes the next scenario when we have a profit. Given 1000 coins with a total investment of $1000, which means a cost of one coin was $1, when coin price rise up to $2, then P&L percent should be 100% and P&L value should be $1000 and holding value should be $2000. How the test should be written in BDD style. First, we describe the starting condition in given block. Next, what we are actually testing is which action, and describe it in when block. Here we should use before test fixture to initialize for every single test its own P&L calculator and get the result. And finally, verify our expectations in then block. We can run our test because we don't have P&L calculator and P&L calculator result classes. So let's create them without any calculation logic, but just for passing the test. Remember, we practice TDD, which means the tests before any implementation. So I will create P&L calculator.dart file where we will have P&L calculator itself, and for now P&L calculator will return result with the hard-coded values just for test running. Let's run our test again, and we will see our test successfully running, but it fails as expected because we don't have any implementation yet. We are in red stage. Next, we have to add minimum logic to make this test pass. So, the holding value we can find as multiplication our coins amount with current new price. The P&L value as a subtraction of holding value with the total investment amount. And the P&L percent as a division the holding value on the total investments. Let's run our test again and check our logic. Great, our profit case is implemented and tested. But for beta testing, we should add some more test cases. And I will leave it again up to you. Let's beautify test report formatting by given when then padding option and rerun the test and get more readable result. Next, let's see, does the actual logic work for loss case? When our coin price fall to 10 cents, then P&L percent should be minus 90% and P&L value should be minus $900 and holding value should be $100. Inside the same given block, we add new when block where we describe our action under the test. And inside the when block, we describe our assertions. Let's run our tests, and we will see our second test is passing. Next, let's test the case with no profit and no loss, which means that the current price the same as we bought our coins before. And then we expect the P&L value and the percent are 0, and we still hold the same amount, $1000. In when block, we describe the action under the test. And inside then block, we describe our expectations. Let's run our tests, and we will see that all tests are successfully passing. Perfect. Let me commit our work and continue the fun. You could notice a code duplication with when and then blocks, which can be reduced if we use test cases. Let's rewrite these tests with test cases. We will leave given block the same. Next, we use test cases with 4 parameters. First one is an input and means the new price per coin. The next 3 parameters are outputs, which are P&L%, P&L value, and holding value. First test case is about profit, the second is loss, and third is nothing change. Inside test case callback, we describe when block with test case parameters, and describe then block with test case parameters as well. That's it. Let's run our tests and see the same test report. But now, without duplication and easy possibility to add new test cases. Like this, by using BDD style with 2 Dart packages, we have improved our test code to make them more readable and expressive. We have got live readable documentation of our software and nice fail messages when something is broken. And in the following video, I will show you how to write unit tests for more exciting and complex scenarios. So far, we've written simple unit tests for simple classes, but most of the classes are not such simple in the real world. Classes are like humans, are sociable. They communicate with each other and have dependencies. But while unit testing, we have to decouple them to test each class in isolation. And how to do that? So stay tuned and see you in the following video. That's it for today. If you enjoyed this video and the video was helpful for you, please like and subscribe. Leave a comment below on what do you think about TDD and BDD. Would you use them? Or maybe you already use them. Please share your experience. If you have any questions, please leave a comment and I will be glad to answer to you.